Although Newton's laws of motion are frequently applied to situations involving acceleration and uniform velocity, it's often necessary to analyze static situations in which all the acting forces are in equilibrium. Using a digital force gauge attached to a taut cable, we can explore an interesting situation involving force components in a cable under tension. By adjusting a turnbuckle at one end, the tension in the cable is brought to an initial value of 100 newtons. Next, an upward force is applied at the midpoint of the cable. The magnitude of the upward force is 20 newtons. In what may come as a surprise, the digital force gauge shows that the cable tension has greatly increased to a value of 220 newtons. The net outcome is that the applied force of 20 newtons has been amplified sixfold, causing the cable tension to increase by 120 newtons. Using a force diagram, the dramatic increase in tension can be explained in terms of the cable's horizontal and vertical components. Because the system is at rest, all of the force components must add together to produce a net force of 0. The cable's horizontal force components cancel one another and play no part in balancing the applied force of 20 newtons. The cable's vertical force components are solely responsible for balancing the upward force. Since the angle of deflection is so small, only a minute portion of the cable's tension pulls in a downward direction. As a result, the cable's tension must become extremely large to provide the balancing force in the vertical direction.